Guys, you're welcome to my channel. Today we are going to commence the concept of circuit analysis. I posted a question on my community yesterday, and I received several comments that I should put solution to the circuit problem. But before putting solution to the circuit problem, in order for you to understand the solution, there's need for you to understand the concept that bets the solution. Solving the problem for you can never be like you understanding the problem and able to solve any question related to that. Now, majority of students or even teacher don't understand more than Ohm's law when it comes to circuit analysis. But as a matter of fact, Ohm's law is not sufficient to solve circuit problem. It can handle basic circuits, but when it becomes complex, it might be tedious to respond to. Then you need other law to support it, such as Kirchhoff's law. But we won't just go directly into Kirchhoff's law. We need to understand something about the topology of network. So we're going to write down in this section, we're going to look at basic network topology. Now, when you talk about the basic network topology, it is very important you understand some basic things in circuits. Now, when we say circuits and we say network, basically, we might be referring to the same thing, though there's a slight difference between them. But as far as this course is concerned, we are going to be referring to circuits as what? Network. So when you talk about network, you're talking about circuits. There are some basic things that you need to understand about what? About a circuit. Such as, number one, you have to understand what we call branch. Number two, you need to understand what we call node. Number three, you need to understand what we call loop. If you understand these three things, it will allow you analyze any given circuit successfully. Now, when you're given a circuit, basically, you are looking for two things, or you are dealing with two things: voltage and current. Then you talk about what can affect both things, both voltage and current. You talk about resistance. So basically, when you're starting up into circuits or knowing about network, you basically be dealing with three things. You deal with what? Resistance, you deal with current, and you deal with voltage. Dealing with current, voltage, and resistance, Ohm's law cannot handle it all, and that's why we need Kirchhoff's law. There's no way you can understand Kirchhoff's law if you don't understand the basic network topology, which are branch, node, and loop. Now, when we talk about branch, what is branch? A branch represents a single element. A branch represents a single element A branch represents a single element in a circuit. Such as voltage, current, and resistor. So these are what we refer to as branch. If you don't want to call it branch, you can as well call it what? Load, or you call it what? Element in a circuit. Are we together now? So when you talk about branch, you're talking about anything that has two terminals. So anything that has two terminals is said to be a branch. For example, if I have a resistor Resistor would have terminal, this terminal A and this terminal B. When you talk about voltage, it also have what? Two terminal. Likewise, when you talk about current, it also have what? Two terminal. Am I making sense now? Now that you understand this, we now need to what? We need to look at a circuit and count the numbers of branch that we have in that circuit. Let's take for instance that I have a circuit like this. Okay, so okay, so just connected the source of currents, and now if this is positive and this is negative, so let's say this one is 5 ohms and this one is 2 ohms and this one is 3 ohms. Then let's say this is current of 2 ampere and potential difference of 12 volts. Now if you look at this, now let this come down better. Okay, now if you look at these circuits now, if you are asked to find the numbers of branch that this particular circuit has, we count what? Voltage, number one, resistor of 5 ohms, number two, resistors of 2 ohms, number three, resistors of 3 ohms, number four, resistor current of 2 ampere, number five. That's to tell you that this circuit has 5 branches. I hope you understand this now. So the circuit has 5 branches, and when you look at each of the branch, you see that they have 2 terminal. So this is a terminal 1 for the voltage, terminal 2 for the voltage. For this resistor, terminal 1, and maybe I should use another color for that. So this one terminal, the second terminal for the voltage, and this will be the one terminal and the second terminal for the 5 ohms resistor, one terminal and the second terminal for the 2 ohms resistor, and this is a terminal and the second terminal for the 3 ohms resistor, and this is a terminal for the 2 ampere current, and this is the second terminal for the 2 ampere current. You now see that everything called branch in this particular circuit, they have 2 terminal. So if you are given a circuit, anything that has 2 terminal in it is called what? Is called a branch. So I hope this will help you understand how to know the branches that we have in the circuit, because in the definition we made mention of just current, voltage and resistor. So I hope that is clear. Now we move down to the next one, which is node. When you talk about a node is the point of connection between 2 or more branches. A point of connection between 2 or more branches is what we refer to as a node. A node is a point of connection. A point of connection between 2 or more branches. Between 2 or more branches. So when you talk about node, we are talking about the point of connection. Now, if you look at this branch here, that is the 12 volt and the 5 ohms resistor, this is their point of connection. So this is a node. Let me label it A. When you look at the 2 ohms resistor and the 5 ohms resistor, this is what their point of connection. Let me call it node B. When you look at 3 ohms resistor, it's also connected to the 5 ohms resistors and the 2 ohms resistor with this node here, node C, and this is node D. There's something I'm going to explain about BCD, but let's move on and just get to understand what they call node first. So this is a point of connection between these 2 ampere current and the resistor 3 ohms. So let me call this one E, and this one is going to be what? F, and this one is going to be EF, and this is G, and this is going to be H. So anywhere you have 2 wires, that means that's a point of connection of 2 branches like this is referred to as a node. In circuits, we always use what? A dot to represent a node. Are you getting this now? So when you see a thick dot in your circuit diagram, it represents a node. You might have it in circuit diagram, you might not have it depending on the examiner's choice. But there's something you need to note about node. Any node, any node that are on the same line like this now, between this node and this node and this node, there is no any branch between them. I want you to understand it in a layman now. I'm not speaking any terminology now. Can you see this now? Between B, C, and D, there's no any branch between them. Are you getting it now? Since they are on the same line like this, without any branch separating them, unlike A and B, you can see that between A and B, there's a resistance of what? There's a resistor of 5 ohms. Between B and G, there's a resistor of 2 ohms. Are you getting this now? But if you look at B, C, D, there is no what? There is no any branch in between them. So you count them as 1, irrespective of what their number might be. Are you getting where I'm coming from now? So this node B, C, D, they are just one node. So this is one node, number 1. This is what? 2. So you not count it as 1, 2, 3, 4. No, because B, C, D, they are on the same line. There's no any branch in between them. So you count them as a single node. I hope you get that. And the same thing goes to C, F, and G. If you look at C, F, okay, not even C, F, G, H. C, F, G, H. There's no any branch in between them. So you count them as 1. I see this now, making 3. So that means in this circuit, the total node that we have is just 3. Now, you see, if I decided, that is, if I choose to redraw this diagram, this circuit diagram in another form, so long I still maintain the same numbers of branches, are you getting it now? And those branches still maintain the same relationship, just like they are now. Like 2 ohms and 3 ohms, they are still parallel to each other. Are you getting it now? So if, and the current that flows through 5 ohms is different from the current that flows through the 2 ohms resistor, I will still have the node to be what? To be 3. Now let's see what I'm saying. I can decide to redraw this diagram, this circuit diagram, in this manner. And this is the reason why you need to understand all this basic network topology, so that it will help you to analyze any given circuit irrespective of how complex it might look. Am I making sense now? Because some circuit diagram can look scary, but when you understand all these terminologies, all these things to look out for, you tend to find them easy to solve. So if I have this to be positive and this is negative, and have this to come like this, so let's have okay, so let's have something like this. Okay, sorry, not getting this right. Okay, so all right, so you can see now this is a node. Let me pick a color for the node. This is a node. Let me just write this. This is 5 ohms resistor, and this is the current 12 volts. This is sorry, the voltage 12 volts, current 12 and 2 ampere, and resistance 2 ohms, and this is resistance 3 ohms. Can you see now? So this is a node. I see it now. This is also what? A node, and this is a node. So you can see this is 1, 2, and 3. You see. So irrespective of how the diagram might come, just understand how to calculate your nodes. So this can be so confusing. Please remember, once there is no what branch between nodes, that is, all the nodes are on a straight line, you count them to be 1. I hope we get that. Okay, so the next thing to look into now is what we call loop. Now, this one is very, very important. You understand it very well, though I will still keep on reminding you in subsequent lecture, should in case you forget. Now, when you talk about loop, what exactly we call loop? Loop is any closed path in a circuit. Loop is any closed path. Any closed path in a circuit. All together now. A loop is any closed path in a circuit. That is, what does loop simply means? Let me break it down so that you get what I'm trying to say. When you say loop, we say it is any closed path in a circuit. Let's take for instance that you start moving from this node A. If you start moving from node A and then node A, which I call the 1, and you move down to what 2, and then you move down to what 3, and come back to what 1. That is, you have 1, 2, 3, 1. I see it now. You move from what 1, then 2, then 3, then back to what 1. This is a loop. Are you getting it now? You just what create a loop. So that's why we said it is a closed path in a circuit. I hope you understand this now. Now, another thing you need to understand is that when you talk about a loop, we said it is a closed path that is formed by starting at a particular node, passing through a set of nodes, and returning back to that same node. That is, returning back to the starting node without repeating any node twice. Let me try redraw this diagram, this cycle diagram, so that we can use this to best explain what we are trying to talk about. All right. So let me put the cycle diagram up again. Okay. So let's say I have okay. All right. Sorry. So that you get to understand what we call loop. Okay. All right. So we have okay. So this is plus negative 12 volts, 5 ohms, 2 ohms, 3 ohms, and the current of 2 ampere here. All right. So this is circuits now. Now, from here like this to this place, this is a node. Let me call it B and call this one A. And from here like this down, this is another node C. Now, if I start my movement, I start moving from A and I journey around these circuits back to A. I just successfully complete what? One loop. If you look at that journey, you see that I did not repeat A twice. I did not repeat B twice. I did not repeat C twice. I only move around them once and go back to where I'm starting from. That is what they call loop. Am I making sense now? So let's take for instance that I want to move from here now like this. So this is a node. Let me pick another color for that. This is a node. This is a node. This is a node. And this is a node. I see this now, though this node here, sorry, supposed to be here. This node here and this node here, they are just one. So if I start my movement from A and I move around to this place, that is a loop. I can also have it here. This is what? A node. This is a node. This is a node. Though this node and this node, they are one, and this node and this node, they are also one. So if I move from this node down like this, get to this node and go back to this one, that is another loop. Are you getting where I'm coming from now? So this is a node, this is a node, and this is a node. So though this node and this node, they are the same thing. Likewise, this node and this one, they are the same thing. So if I move from this node back to this node, you are creating what we refer to as a loop. I hope we all understand what we call loop in this manner now. All right. So when you understand what we call a loop, there is a general formula that every network that has independent loop, any network that has what? Independent loop is said to what? And when I say independent loop means that loop is having what? A single branch. Are you getting it now? A single branch. So if it has a single branch, that is, the branch is not in another loop, it tends to have what? An independent loop. Then if I have a network, if that is the case, if I have a network, remember when I say network, we're talking about a cycle. So if I have a network with B branches, if I have a network with B branches and N nodes and L loop and L loops, remember these loops has to be independent. It will satisfy the fundamental theorem of network topology, of network. Am I getting this network right? No, I guess there's a mistake in the spelling. So network topology. I hope we get this now. So what's the fundamental theorem of network topology? It says that the numbers of branch in a circuit is equals to L plus N minus 1. So that is the numbers of loop plus the numbers of the node minus 1 is going to give you the numbers of branches that you have in such electric the network. So in such network topology. And when you look at this right here, we have 3 nodes. These 3 nodes, and we have 3 loops. So B equal 3 loops plus 3 nodes minus 1. That gives us what? 5, which is the numbers of branches that we have in this circuit. Do you get that now? So you can see this is 1, this is 2, this is 3, 4, and 5. So it's as simple as that. Now, let's take a look at some questions before we call it a day. But before we look at the questions, I would like to quickly recall the definitions. And we start with the word branch. And we said branch is what? It represents a single element in what? In a circuit. When you say branch, you talk about a single element in a circuit. It can be resistor, it can be voltage, it can be current. And we can also say that branch is any element that has 2 terminals in what? In a network. Are you getting it now? And we said node. So we said that node is the point of connection between 2 or more branches. The point of connections between 2 or more branches is what we refer to as node. And loop is any closed path in a circuit. Any closed path in a circuit. A loop is a closed path formed by starting at a node, passing through a set of nodes, and returning to the starting nodes without passing through any nodes more than once. I hope you understand this. Now, there's something I forgot to tell you about this. You know, the example we have earlier, let me just go up. If you look at the loops that we have here, the loops that we have here, they can be broken further. Are you getting it now? So any loop, like for example now, if I move from A and I move like this down back to A, such loop can still be break into further loop. But if I move from A in this particular place, I'm talking about the loop I formed there, that is the first loop I formed in this place, it's called a mesh. It's called what? Mesh. And what do we mean by mesh? When you say mesh, mesh simply means a small loop that cannot be broken further. A small loop that cannot be broken further is called mesh. So you need to understand all of these things very well, because as we move on in the class, we're going to be talking about super mesh, super node. We're going to be talking about mesh analysis, nodal analysis, Thevenin's theorem. We need to understand all of these terminologies now. So when you say mesh, you're talking about what? A smaller loop that cannot be broken further. I hope you understand that. All right, so fine. If you understand that, so let's take some questions and let's see how far you really follow this lecture, and then we can call it a day, and I can be satisfied that you now understand the topic, the basic network topology. Sorry. So this example states that we should find the numbers of nodes and the numbers of branches, the numbers of nodes and the numbers of branches in these given circuits. Okay, so we have this. Okay, so this is positive, this is negative. So we have this place to be 10 volts, and here is 5 ohms, and this is 6 ohms, and we have a current of 2 ampere. Now, the question states that we should find the numbers of branch and the numbers of a node. So you can pause the video and let me know your answer. Then when you're done, you can keep watching the video. So let's count the numbers of branches we have here. 10 volts is a branch, 1. 5 ohms is a branch, 2. 6 ohms is a branch, 3. And 2 ampere is a branch, 4. So it means we have 4 branches. 4 branches. The 10 volts, the 5 ohms, the 6 ohms, and the 2 ampere current. These are the branches that we have. What about the numbers of node? So the 10 ohms and the 5 ohms, they meet here, and that is the first node. And the 5 ohms and the 6 ohms, they meet here. Likewise, the current of 2 ampere meet here. So you count this one to be 1, since there is no any branch between them. So this is going to be 2. And this, and this, you count them to just be a single node. So that will be what? 3. So we have how many nodes in total? We have 3 nodes. I hope you get this now. So we have 4 branches and 3 nodes. I hope this is clear. All right, so if that should be the case, let's try this last example. And okay, if I may ask, how many loops do we have here? How many loops do we have? Fine, so we have 2 loops. So you move from here, 2 independent loops. These are the independent loops. We call them mesh. Mesh. So do you understand that now? The independent loop are also known as mesh, or you say loops that cannot be further broken into smaller parts. I hope you get that cleared. All right. And if you look at the formula that we talk about, branch is equals to the number of loop plus the numbers of node minus 1. So we have 4 branches, right? And we don't know the numbers of loop plus how many loop, sorry, how many nodes? 3 nodes minus 1. So that will be 4 equal L plus 2. And L is just 4 minus 2. And that is just what? 2. I hope somebody understands this clearly. Okay, so let's try this last example and let's see if you have made a mistake in the first one and you get to see the correction now. So don't repeat the same mistakes on this. So, okay. All right, so I have this. and I have this. Okay, so let's say, okay, this is another one, yeah, and here I have a voltage 10 ohms, 10 volts rather, and here I have a 4 ohms resistor, and this is 5 ohms resistor, and this is 2 ohms resistor, and this is 1 ohms resistor. Sorry, so 1 ohms resistor. So the question still remain the same, unchanged. How many how many branches and how many nodes do we have? So pause the video and try to give answer to the question, and when you're done, you keep watching. So this is going to be 1, 2, 3, 4, and then 5. So we have 5 branches. All right, sleep tight. Bye bye. Sorry, Blues. All right, so 5 branches. 1, 2, 3, 4, 5. How many nodes? So let's check. So this 1 ohms resistor meets with 5 ohms resistor here. Likewise, the 2 ohms resistor also meet the 5 ohms resistors here. So between this and this, there's no any branch. So we count this as a 1. So that's the first node. And between this and this also, there is no any branch. So we count this as 1 also. That's what? 2. And between this and this, everything is just straight. There's no any branch between them. So this is going to be 3. So we have 3 branches. I hope this is cleared. And if you want to know the numbers of loop that we have here, you get to see normally 1, 2, and then 3. So we have 3 loops. So if you also want to use the fundamental topological formula, that is L plus N minus 1. So you have 5 branches. Then you don't know the numbers of loop, but you know the numbers of node, and that is 3 minus 1. So you have 5 minus 2 equal what? L, and that will give us 3. So I hope everybody understand these aspects now very well. So thank you so much for watching to this point. If there's anything you're confused about, let me know in the comment section. And if you still don't understand Ohm's law, you can let me know in the comment section before we move on to the Kirchhoff's law. Until then, see you guys tomorrow.